price is greater than marginal revenue for a monopoly. We can show this by calculating marginal revenue when output goes from 10 to 13, which makes price fall from 100 down to 97. So first we want to calculate the total revenues. Total revenue is simply price times quantity. So 10 times 100 is going to be 1,000. And 11 times 99 is going to give me 1089. And 12 times 98 gives me 1176. And 13 times 97 gives me 1261. Now, marginal revenue is the change in total revenue over the change in quantity. Since output's rising by 1 in each of our, as we go from row to row, this marginal revenue is simply going to be the extra revenue we get as we increase output by 1. So output revenue goes from 1,000 to 1,089. That means that marginal revenue is $89. When output goes from 11 to 12, output rises by a total of $87. And when output goes from 12 to 13, output rises by a total of $85. Notice that marginal revenue is always lower than price. For example, when output goes from 11 to 12, the marginal revenue is $87. 87 is less than 99. It's also less than 98. It's lower than either of the prices for the quantities that we used to compute the marginal revenue. Since price is always greater than marginal revenue, the marginal revenue curve will be below the demand curve for monopoly. Let's see what this means. Here's quantity. Here's various dollars amount. Here's downward sloping demand facing the monopoly. And let's just say, so here's quantity of 10. Here's quantity of 11. We go up, we get a price of 100 when quantity is 10. And we get a price of 99 when quantity is 11. Well, the marginal revenue of going from 10 to 11 is $89. Let's plot that 89 halfway between 10 and 11 because it's really the marginal revenue of going from 10 to 11. So here's 89 down there, right in the middle. Notice the marginal revenue value is below the point in the demand curve. The marginal revenue curve every point in the marginal revenue curve will be below the demand curve because price is greater than marginal revenue. Now this relationship we described is true for monopoly, but it's very different for perfect competition. Price equals marginal revenue for perfect competitor. We can show this pretty quickly. When quantity is 0 and market price is 8, total revenue is 0. If the competitive firm can sell as much or as little as it wants at the market price of $8, so total revenue goes to 8, it goes to 16, it goes to 24. When we take the change in total revenue over change in Q, we'll take 8 and divide by 1, which is equal to 8. We'll take 8 and divide by 1, which equals 8. And again, we'll take 8 and divide by 1, which equals 8. Price and marginal revenue are the same for all levels of output. They both equal 8, regardless of the level of output. Now, let's see what this means for the perfect competitor. We got quantity. We got dollars. Here's our demand curve. That demand curve is also the marginal revenue curve. They both equal, price and marginal revenue both equal 8 for all levels of output. The equivalence between price and marginal revenue explains why a perfect competitor maximizes profit by producing the quantity where the demand intersects marginal cost. That's called that QM. If we're to the left of QM, that means that price equals marginal revenue is greater than marginal cost. In that situation, when you increase output, your total revenue is going to rise by more than your total cost is going to rise. So your profit is going to go up as you produce more output. On the right side of that line, we'll do it in green here. Now we have price equals marginal revenue is less than marginal cost. Well, that means when quantity goes up, we're going to have the increase in total revenue is going to be less than the increase in total cost. And that means profit will go down as we increase output. So as we move to the right, as we go this direction, profit rises. As we go further, profit falls. The optimal level of output is right there where marginal cost crosses the demand, because that's where marginal cost crosses the marginal revenue curve as well.